So what has a derivative of sine? Negative cosine. When you do the derivative of a trig function, the angle doesn't change. So that would have to stay the same. So if we did the derivative of cosine is negative sine, so 2 would make it positive, inside stays the same, times the derivative of the inside. What's the derivative of 2 pi x plus 2? 2 pi. So to cancel that, we need a 1 over 2 pi. So it's negative 1 over 2 pi cosine 2 pi x plus 2 with a plus c on the end. So remember chain rule in reverse. Always a good idea to just kind of check yourself. Think about, if I did this derivative, do I get back my original problem? This one I would rewrite. Negative 1 over x squared could be rewritten as x to the negative 2. When you do the derivative, you subtract 1 from the power. So the antiderivative would add 1 back, so that would be a negative 1. When you did the derivative, that would come down, so we need to cancel it in front, so that's just a negative. So that would give me x to the negative 2, so that works. We're evaluating from negative 2 to negative 1. All right, negative 1 to the negative 1. So that's just 1 over negative 1. Oops. Minus, if I put in my negative 2, you get a negative 1/2. So we get the opposite of negative 1/2 or positive 1/2. Is that one okay? Number 6, the integral from 1 to 3. 10 over 2x plus 3 squared dx. I would at the very least rewrite this as 10 times 2x plus 3 to the negative 2. So when we do our antiderivative, that 10 is just going to stay as a coefficient. Add 1 to the power, so that's 2x plus 3 to the negative 1. So we need a negative in front to cancel that. Think about your chain rule. Derivative of the inside is 2. So to cancel it, we need a 1/2. So we would have to divide by 2. So we have negative 5 times 2x plus 3 to the negative 1. So if I evaluate that, a negative power puts it on the bottom. If I put in a 3, I get 1/9. Minus, if I put in a 1, I get 1/5. Common denominator, so this is like 5 over 45 minus 9 over 45. So we get 20 over 45 or reduced to 4 over 9. So what's getting guys on these? Is it the chain rule, undoing the chain rule?
Every time I had a negative exponent, instead of adding one to it, I subtracted one. So I just said that.
Well, now we know what you did. You were doing the derivative instead of the antiderivative. Problem 7. So this is the absolute value one, so we just got done doing. And we know we have to separate it when we get 0 on the inside. So that is at 3. So I'm going to integrate from negative 1 to 3 and from 3 to 5. If I put in something between negative 1 and 3, so even like a 0, 3 minus 0 is positive, so does the absolute value change it? No, so it just stays the same. If I put in something between 3 and 5, so a 4, you get a negative. The absolute value makes it positive, so it does the opposite. So it's the opposite of the 3 plus, or 3 minus x. or you can distribute that negative if you would like. So antiderivative, so this would be 3x minus 1/2 x squared. This one would be a negative 3x plus 1/2 x squared. Alright, so if we plug it in, I put in my 3 and my negative 1. Over here, if I put in my 5, minus, put in the 3. So then if we calculate, we get 10. Number 8. This one we have to do more simplifying up front. Because when we look at this, I have an x on the top, I have an x on the bottom. To do the derivative, you would have to do the quotient rule, right? Do we have a rule for quotient in reverse? No, we can't undo the quotient or the product rules. So, first let's multiply this all out. So if I FOIL the top, I would get 4 plus 8 radical x, not 4, sorry, 16 plus 8 radical x plus x over 2 radical x. So if we simplify that, there's only one term on the bottom, so we can break it up. 16 divided by 2 square root of x, so that would give me 8x to the negative 1/2. Do you guys see where I got my negative? A square root is like a 1/2 power. Since it's on the bottom, it's negative. In the middle term, the radical x cancels, so we have 8 divided by 2, which is 4. In this one, we have a 2 on the bottom, so that's like a 1/2. X to the first minus x to the 1/2 is x to the 1/2. So now, add 1 to the power, so that would be a positive 1/2, which means we need a 2 in front, times the 8 would be a 16. Antiderivative of 4 would be 4x. X to the 1/2, if I add 1 to the power, that's 3/2, so we need a 2/3 in front, times my 1/2 will be 1/3. I did a couple steps together there. Do I need to show you where any of that came from? Okay. Then if we just evaluate, this is like 16 times the square root of 4, so 16 times 2 is 32, plus 16. Square root of 4 is 2, cubed is 8. Put in a 1, square root of 1 is 1, so we get 16 plus 4 plus 1/3. So 91/3. And you guys, are you okay with my mental math, or do I need to explain any of that? Common denominators. Is there anything else on that first page? Second page, question number 11. This one was a little bit tricky. So we need a sum. We add from 1 to what? How many terms do we have? 9. Okay, they are all similar in that they have 1 over a square root of something. So now we need a formula for that something. I is the term number. So this is a 1, 2, 3, 4, 5, 6, 7, 8, and 9. All right, I need to figure out how I can use that number to get this one. So one thing I noticed is these are all 1 less than a perfect square. So 3 is 1 less than 4. 9, 16, 25, 36, 49, 64. So those are perfect squares. So I probably have something squared in them. All right. Now, if I do 1 squared, I don't get 4, do I? What would I have to do? We have to add 1. So 1 plus 1 is 2, squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. So we've gotten close, but these are all 1 less than that, so now what do we need to do? So it's over the square root of I plus 1 squared minus 1. So if it's not an obvious one, my suggestion is write out your I's and then think about how can I use this number to get that one and try to come up with a formula. And problem 15. We know our function is 9 minus 4x. Our interval is 1 to 2. And it tells us we have to do the limit as n goes to infinity of the sum from 1 to n of f of x sub I times the change in x. Now, at this point, we do know that that's an integral, but if I tell you to do this, you have to do it that way. Now, that doesn't mean you can't do the integral off to the side and check your answer, but if I say specifically use this form, then we have to use it. So we need to figure out a few things. We need to know what x sub I and change in x are. So change in x will be 2 minus 1 over n, so 1 over n. X sub I is our starting point plus the change in x times I. So 1 plus 1 over n I. So you have to get those two pieces to put into our formula. So f of x sub I says I go to my function, and I change my x to the 1 plus 1 over n I times my change in x, which is 1 over n. The hardest part about these is really just the algebra. Now we just have to carefully multiply things out so we don't make mistakes. So that would be a minus 4 over n I. Okay, 9 minus 4 is 5. Can I distribute my 1 over n with that? So it would give me a 5 over n minus 4 over n I times 1 over n would be 4 over n squared I. Now we are going to do the summation. If you made a mistake on this problem, I'm willing to bet it's right here. The most common mistake, we are adding up i's. 5 over n does not have an I in it. So that means when you're adding it up, you're doing 5 over n every time, right? So when I add that up, what do we have to do? Times n. So it's the 5 over n times the number of times we added it. Minus my 4 over n squared I. This is where we have to know our summation rules. What's the formula for I? Now, it's back to algebra. So 5 over n times n is 5. Minus, so I can reduce an n to be a 2. 2n plus 2 over n. Distribute your negative and divide by n, so we get 5 minus 2 minus 2 over n. If n goes to infinity, anything with an n on the bottom is turning into 0, so we have 5 minus 2, or 3. So this is how we did our integrals before we knew the definition. Probably won't be a ton of them on the test, but you should expect to see it, and it's worth a decent amount of points because there's quite a few steps there. Anything else on 1 through 15?